Alrighty, this is the last video for this section, at least for the algebraic part. Later on, we're going to be doing applications of this, such as finding the heights of buildings and angles and other stuff. So let's do another example when it involves understanding these ratios that we get by these triangles that are formed by rotating that ray on our angle on our first quadrant, because all those angles are less than 90 degrees, which is what we're focusing on right now. So if we start rotating, we're going to be forming different triangles at different points along the edge of the circle, and we're interested in the ratios. All right, using these ratios, what is the value at those points, and all the values that we get as these ratios, we're going to call them the sine values, and all the values that we get for the ratio, of cosine, we're going to call them the cosine values. So let's do this. So this is a typical problem. Let theta be an acute angle. So what does that mean? It just means that it's less than 90 degrees, such that sine of theta is equal to 5/6. Evaluate the other 5 trigonometric functions at theta. So what are they even asking? They're pretty much saying, hey, I'm not telling you the angle measurement, but I'm telling you that when I rotate the ray on the terminal side all the way to a certain degree, I get a nice little triangle that has these properties of 5/6 for my function of sine. So they're saying sine, sine, sine. What is sine? Well, sine is opposite over hypotenuse. All right, so that means that we're gonna have to use the Pythagorean theorem. Pretty much they're saying, hey, this is your opposite over hypotenuse. What does that mean? That is, if this is theta, what is my hypotenuse? Remember, I always go by that. Where's my hypotenuse? Directly right here. So that is 6. What is that 5? That 5 is my opposite. My opposite is directly across. So ta-da! So now this is what they're saying. And as you can see, we have the 5 and the 6. Can we solve for that last side, x? Of course we can. And to do that, we're going to have to use the Pythagorean theorem. Using the Pythagorean theorem for a squared plus b squared equals c squared, we're going to get that third side is equal to square root of 11. And I leave that up to you to be able to do that. So let's see, what is this? Well, we know the sine. Oh, I even wrote it here. Look at that. Amazing, amazing, amazing. Sine of theta, this mysterious angle that we don't know, yet we do not need. All right, that is amazing. Sine of theta is equal to opposite over hypotenuse. Well, let me look at this. My opposite. Well, didn't they tell us that it was 5/6? Yay. And look at that. If you know the sine of theta is 5/6, automatically, as a bonus, you know what is cosecant of theta is 6/5. It's the reciprocal. Amazing. Cosine of theta. Cosine is adjacent over hypotenuse. Well, adjacent, adjacent, adjacent. If this is my hypotenuse, this is the opposite, this is the adjacent. It must be square root of 11/6. Ta-da. This does not look right. Square root of 11/6. Beautiful. Tangent, 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 opposite over adjacent, and we get a 5 over square root of 11/11. I completely rationalized already. So moving forward, correct notation, we're going to stick to the rationalized version. I do not want to see a radical on the denominator, even though in today's date and age, whether I have the rational, the radical on the numerator or the denominator doesn't matter. We have computers that can calculate that. This used to be a big deal back in the day because they had to do those calculations with the radical inside, and it was just a little complicated. But now it doesn't really matter. We just establish more for notation and clarity. And it also tells me that if you gave me the 11 on the bottom instead of square root of 11, that you know how to multiply by a radical of a over radical a, and that is multiplying by 1. So yay, you show me how to multiply by 1, which is good. And remember, the reciprocal ones are just the reciprocal. So what is secant of theta? We must be 6/√11. And if we rationalize, we get 6√11/11. Ta-da. And the last one is, well, just the opposite of this one, which is 11, the reciprocal. Look at me. Times 5√11. Well, what is the part that we do not need here? Here is the √11 on the bottom, right? So we multiply by √11 by √11. And on the numerator, we have 11√11 over 5 times. Well, what is 11 times, what is square root of 11 times square root of 11? Is just 11. So it's 55, right? So we have 11 root 11 over 55. 11 and 55 is 1 over 5. So we end up with root 11 over 5. Ta-da! That is all for these ones. We're going to be doing application problems next. So let's make sure that we understand how to calculate these ratios. Essentially, what you're doing is you're solving a Pythagorean triangle and you're finding what the ratios are of the sides. Because remember, all these ratios sign, when we move into the circle, we're going to be just referring to the value of the ratio. So yeah, let's pause the video, rewatch it again. I love when I see those statistics. I love analyzing the analytics, and just it makes me happy, and it's interesting to see behavior in such a graphical way. I'm seriously thinking of just based on data, maybe perhaps write a curriculum at some point on that, or just incorporate more into my curriculum data statistics analysis based on social media analytics that anybody can have. If you have different social media platforms, it tells you your analytics if you have the pro version or whatever it is, and it's just quite nerdy to just geek out on that, and it's amazing. So I'm thinking that. So yeah, keep watching them, and yeah, if you have any questions, do reach out. Leave comments again. Subscribe. Help me grow here. Come on, help me. But yeah, no, and just the more you like it, I guess the algorithm, the more it puts it out there, the more people watch it, the more people benefit. So we can help the world math a little bit more. Why wouldn't we? All right. It's already a math world. Why not make it mathier? Matter? All right. Have a good day, guys. And be on the lookout for the future videos. Thank you.